Hello once again. Thank you for joining us. This is the Space Nuts podcast, all about astronomy and space science, what's happening in the wider universe or in your backyard, perhaps. My name's Andrew Dunkley, your host, and joining me as always is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How are you doing?
I am very well, sir. How are you?
Yeah, equally well, probably.
That's good. That's good.
Slightly older, but equally well.
Only slightly. Yeah. In universal terms, it's very slight.
It is, that's right, yeah.
Super slight. Now, before we get on to today's topics, I've got something to show you, which won't help people listening via the podcast or the radio network, but if you're a YouTuber, you'll see it. I am in uniform. Look. Check it out.
Oh, wow. Wow, fantastic. The Space Nuts shirt.
Yes, I've got a Space Nuts shirt with an embroidered logo. And apparently you're getting one soon too.
I believe I am, yes. I believe there might be one coming for me.
It's only taken us 5 years to make enough money to pay for a logo.
And to pay for one each for us.
One each as well, yes, exactly right. Now, coming up on this particular edition of Space Nuts, we're going to look at an incident involving the International Space Station. They've had a little bingle. Plus, the search for the origin of the asteroid that polished off the dinosaurs, and not in a good way. No polish involved, in fact. It was a huge mess. And we're going to answer some audience questions. One about, it's sort of a multi-pronged question about pulsars and quasars. What's the difference between them? How does matter escape a black hole? And, a few other things involving black holes, pulsars and quasars, and we'll get onto that. And we've got a question from the United States about explaining the heliopause and the journeys of Voyager 1 and Voyager 2. And it's a great question because I don't think we've ever been directly asked to explain the heliopause before. I won't be doing that, but Fred will be. So we're going to cover all of that today on the Space Nuts podcast. But first, Fred, let's head out to the International Space Station, and there's been a little bit of a hiccup.
Yeah, there has, which has sort of set back a program that's of great interest to all of us, which is getting the Starliner up there to do a test flight, which is Boeing's answer to the Crew Dragon module that SpaceX runs up and down these days to the International Space Station. So what happened was a new module for the space station, and it's a Russian one, so it goes on the Russian half of the space station, whose name is, I think I'm right in saying it's Naoko. It is, I'm not sure whether I'm pronouncing that correctly, but it looks like Naoko to me. And what happened was that module, essentially, it's a big piece of kit. This thing's 13 meters long and weighs 20 tons. So it's not just a tin can that's being attached to it. It's a tin can, but a very big one. And what it will do is give the Russian segment of the space station much more space. It'll open it up, and most importantly of all, Andrew, it carries an extra toilet as well. So that's really, well, you can't have too many of those things.
You cannot have too many bathrooms on a space station, I'm sure.
Yes, exactly. So what happened was the Naoko module headed up there on, I'm not sure what the launch vehicle was, but it made rendezvous with the space station. Did all its stuff. This is a few days ago now. But once it had docked with the International Space Station, this was about 3 hours after everything had gone. The flight itself took 8 days to get from the surface of the Earth. Naoko docked with the space station. Everybody had a cup of tea or whatever you do when something like that is just finished. But then it started firing its rockets without a command to say fire your rockets. These are thrusters that are on that Naoko, and they began firing at I don't know whether it was full power, or because I don't even know whether these are throttleable. They might be on or off. Anyway, it fired for a matter of minutes before a command was given to kill everything and cut the motors, and that then resulted in of course a recovery operation, which happened very quickly. What it did, Andrew, was not to shove the space station off its orbit. That would probably have required a bit more oomph to do that. But what it did do was change the attitude of the space station. In other words, it tilted it over with an error. It moved it by 45 degrees. And you can easily imagine that, because this module, its thrusters, when they fired, would not fire in the line of the center of mass of the space station, which is what you'd need if it wasn't going to change the attitude. Any other thrust is going to tilt it one way or another. So yeah, 45 degrees, which is quite significant. Now, of course, in space, it doesn't matter which way is up, because you're weightless. However, the space station has to be kept at the right orientation. It's all about the solar panels and the orientation with respect to Earth and things of that sort. So there was another operation with thrusters on board another Russian segment, which is Zvezda, and a Progress freighter that's also docked. They basically, the rocket motors on those segments were used to bring the space station back to its proper orientation. And the whole thing was over in less than an hour, in fact. It was really quite very, very neatly done. NASA's tweet about it was, space station crew members are safe and will scrub their schedules for today in order to focus on recovery efforts following the unexpected loss of attitude caused by the Russian Naoko module's thrusters firing. Station is back in attitude control and is in good shape. So all is well, but it apparently, in a later report I read, it seems to have traced the erroneous firing, or the errant firing of these thrusters to a software issue, which is exactly the kind of thing that you might expect.
I was betting on somebody flicking a cigarette out the window.
Well, you never know. Yes. Meanwhile, back in the real world, there's quite a long story with Naoko, because it should have launched 14 years ago.
Wow.
But there were all kinds of slips in schedule, budget difficulties, technical problems, the whole thing. And apparently, even after its launch, I remember I said it took 8 days to get up to the space station. Actually, it doesn't take that long to get up there, but then you've got to do all the catching up with the space station and orientation and everything. Yeah. Apparently, on its way up, it had propulsion issues, which, as the BBC said, required workarounds from controllers in Moscow. But it did arrive on the planned schedule.
Sounds like it was built by a Russian car company.
Well, I won't comment on that. That could be right. What it does do, it raises the volume of habitability on the space station by 70 cubic meters. So this is quite a significant addition. And as I mentioned, there's an additional restroom there for crew use. What else was on board was an 11-meter long robotic arm, which is called ERA, which I suspect is the European robotic arm, because it comes from the European Space Agency. And that's something that is a device that's built for external operation around the Russian segment of the space station, which has obviously got fittings on the outside that this thing will link onto. It's got, it's interesting, the structure of it. It just looks like a large pair of compasses, if you remember what they look like.
I remember those things.
Yeah, and apparently, the ends of the two arms grab onto fixtures on the external part of the Russian modules, and it basically grabs one, pulls itself along, grabs the other, pulls itself along. So it walks along the outside of the module, moving hand over hand, as the BBC report put it. Quite a nice way of putting it.
How impressive!
Yeah, it's great. The one thing that has happened is, as I mentioned, it's pushed back an uncrewed test flight that was scheduled for last Friday of the Boeing Starliner capsule, which is an equivalent of the SpaceX Crew Dragon, and that was the earliest date that they could do it, I think, was probably today or maybe yesterday, and I haven't heard whether that launch has taken place. So I suspect it's still on hold.
So I wanted to ask you about the Starliner. This is essentially going to be a transport vehicle.
Yes, it's able to carry crew. So in the same way that the Dragon capsule can carry cargo or crew, there are different versions. This will be the same. I have to say I don't know that much about it. I think Starliner is specifically just backtracking there to 2011 when the new version of NASA was wheeled out, where the commercial sector was going to be essentially co-opted to carry out transport of astronauts up and down to the space station using commercial vehicles rather than NASA sponsored ones, even though NASA's funded it. The two companies that sort of won out, actually there were three, because what was then Orbital Dynamics also had a module. That's changed hands now. I think it's part of Northrop Grumman. I might be wrong there. These things need a bit of attention to keep up with them. But the two ones that were in the lead, I mean, SpaceX kind of won the race, as it were, with their Crew Dragon, which has now made at least 2 crewed flights to the space station, maybe more. Boeing was the other winner in the contracts race, but also is about to test out their Starliner. It's a nice name, isn't it? For a spacecraft.
Yeah, I like it. Just by the by, my son, not long after he moved to Sydney, worked for a company that had a contract with Boeing Aerospace. So he did actually work for Boeing on some of their aerospace contracts some years ago. Yeah, I don't think it was, I think it was mainly ordering parts and bits and pieces and things like that. But he might have had something to do with the Starliner and not even know it.
Who knows? Yes, he might not even know it.
Fascinating work. And I think when you were trying to think of a way to describe the re-gearing of NASA so that all the transport sort of went to the private sector. Yeah, they call that outsourcing.
Ah, yes, I've heard of that.
Outsourcing. Yeah, so everything is well. That's good news with the ISS. Of course, the journalist in me has just come up with a list of what-if questions. What if they couldn't shut it down? What would have happened then?
Well, it would have eventually run out of fuel, and it could even have sent the space station into a spin. And doing that would have meant some very quick thinking on behalf of the controllers who sit watching these things at all times, both in Moscow and down in Houston. The thing they'd have had to do was work out which thrusters elsewhere on the space station you need to fire to oppose the torque, the rotation that's being provided by the errant one.
It's pretty scary, and I imagine initially they would have been absolutely stunned by what was happening. But from what I've read, the way they reacted and dealt with it was extremely brilliant and clever. And they would have all sorts of safety protocols, and they would do all sorts of drills regularly to cover all possible contingencies. And obviously they'll do an investigation, they'll learn from this, and they'll be more ready next time. If there is a next time, and you hope not, but I would imagine the training that they go through and the protocols that they would have, and if all else fails, their escape plans would be something that would be very well drilled into the astronauts and cosmonauts. So it's all credit to them. They solved this problem brilliantly. From what I've read, fantastic job.
It looks like it, yeah. I mean, it's sort of akin, the way pilots are trained. The first thing you learn is how do you get out of a spin, or how do you correct a roll or something like that. Stall. So, and that's drilled into them from the word go. And I guess the same kind of thing probably happens on the space station. Next time I'm talking to an astronaut, I'll ask him or her.
Yes, indeed.
In fact, I was talking to one last week, but he didn't listen to what I said because he was on a webinar.
Fair enough. Anyway, it's all good news for the ISS. A little bit of a dust up, but back to normal now.
Yep.
This is the Space Nuts podcast. Andrew Dunkley here with Professor Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.